Now, let's look at an example on theorem number 4. Here we are given that O is the center of the circle FGHI. Therefore, O is the center of circle FGHI. With diameter FH, we are given that FH is a diameter, and also GH, which is a chord. Now, this is one of the example of theorem number 4, which include also theorem number 3. It means that we've got 2 theorems in one here. But we will see how can we solve that. They say to us, name with reasons 2 other angles equals to x. The first angle that is equals to x, I know we are dealing with theorem number 4, therefore angles at the same segment. Therefore this angle is equals to that angle, since they are opposite or they are subtended by the same arc or by the same chord. Now, G angle I, H is equals to G angle F, H. G angle I, H is equals to G angle F, H. So this angle is equals to that angle. Reason, angles at the same segment are equal. Angles at the same segment are equal. You can write equal as in a name form, or you can write it like that. Now, G angle I, G angle IH is equals to x. Therefore, it means that G angle FH is equals to x. So G angle FH is equals to x. Another angle that is equals to x is this angle there, F angle GO, which is this angle there, is equals to x. So we know that this angle is x there. So this angle as well is x there. Obviously, why is that? We will give a reason. Therefore, we're going to say G angle F, G angle FH is equals to F angle G O. Reason? The reason for this, because we're saying this angle is equals to that angle. Triangle FOG or GOF, triangle GOF is isosceles, is an isosceles triangle with FO equals to OG, radii. We know here radii. Therefore, it means that base angles of a isosceles triangle are equal. Now, G angle FH, G angle FH, we know it is x. F angle GO, that's what we were looking for, which is equals to F angle GO. F angle GO. This is another angle which is equals to x. So this angle is equals to that angle. Angles at the same segment are equal. this angle is equals to this angle there. OFG is an isosceles triangle with OF or with FO equals to OG, radii. Now, B. Show that O angle GH, O angle GH, this angle there, is equals to O angle HG is equals to this angle, which is equals to 90 minus x. So we must show that this angle there and this angle are equal. But they are equals to what? They are equals to 90 minus x. Right. What we know is that this angle is x, as we have said it there. Therefore, we can find F angle OG. F angle OG plus O angle FG plus F angle GO. F angle GO is equals to 180 degrees. So here we mean that F angle OG, which is this angle, plus O angle FG, which is plus this angle, plus F angle GO plus this angle is equals to 180 degrees. This angle plus that angle is equals to 180 degrees. Reason, I'm going to write the reason on top there. Sum of angles on triangle OFG. Sum of angles on triangle OFG. Now, we know we are looking for F angle OG, which is this angle there. F angle OG plus, we know O angle FG. O angle FG is X plus F angle GO, F angle GO, it's another X there, which is equals to 180 degrees. Now, F angle OG plus 2x is equals to 180 degrees. Now, F angle OG is equals to 180 degrees minus 2x. I take this to the other side, which becomes minus 2x. Therefore, this angle here, this angle there, it's 180 minus 2x. Now, therefore, O angle GH, O angle GH is equals to O angle HG. Reason, triangle OGH is isos where OG is equals to OH. We know radii. OG and OH, those are our radius, but since there's two of them, radii. Now, OF angle OF angle OG, which is this angle there, which is an exterior angle of a triangle, of this triangle. It's an exterior angle, it's outside this triangle. Therefore, this angle is equals to this angle plus that angle there. This angle, which is this angle, is equals to this angle plus that angle, exterior angle of a triangle. Therefore, F angle OG, which is this angle, is equals to O angle GH plus O angle HG. Risen, exterior angle of triangle. Which triangle is that? OGH. OGH. Exterior angle of triangle OGH is equals to the sum of opposite interior angles. This angle is equals to this angle plus that angle. Exterior angle of a triangle, is equals to the sum of the opposite interior angle. Therefore, we know that this is equals to that. Then we can have 2 O angle GH, because we can put O angle GH here. This plus this becomes 2 O angle GH, which is equals to F angle OG. And F angle OG is 180 minus 2x. But we were told to show that O angle GH is equals to O angle HG equals to 90 degrees minus x. Therefore, it means that here we can divide by 2 there, where we are going to have this cancelling with that. O angle GH is equals to 90 degrees minus x, which is also equals to O angle HG. Now let's look at the example on theorem number 5. Here we are given that JMJKL is a cyclic quadrilateral, and if we are given that MJKL is a cyclic quadrilateral, we know that we've got a cyclic quadrilateral. Now, we are also told that triangle JKL is an isosceles triangle, and if it's an isosceles triangle, obviously JL is equals to KL. We are also told that JM is parallel to KL, and we can see by these arrows that JM is parallel to KL. By these arrows, they're telling us that those two sides are parallel. Also, we can see that JL is equals to KL by this strokes there, which I used there. Now, J angle LK, which is this angle there, is 50 degrees. Now, we are to find X with resonance. We are told to find X with resonance. Now, for us to find X with resonance, we know that since JKL is an isosceles triangle, it means that this angle here is equals to that angle there. Therefore, it means that L angle JK is equals to J angle KL, because JL is equals to KL. Now, let's write it down. L angle JK is equals to J angle KL. Risen. Why are we saying this angle is equals to that angle, or reason is that triangle JKL is isosceles triangle, where JL is equals to KL. Now, we know that J angle K L plus K angle L J plus L angle J K is equals to 180 degrees. This means that J angle KL, which is this angle, plus K angle LJ, this angle, plus L angle JK plus this angle. So this angle plus this angle plus this angle equals to 180 degrees. Reason? Sum of angles on triangle JKL. Now, we know that L angle JK is equal to J angle LK. So J angle LK is equals to this angle. Therefore, I can put J angle KL, because this plus this is going to be the same. These two are the same. Therefore, this plus this is going to give me 2J angle KL plus K angle L J, which is this angle, is equals to 180 degrees. Now, we know this angle that it is 50. Therefore, 2J angle K L plus 50 degrees is equals to 180 degrees. We are finding this angle there. Sorry, this angle there. We are finding this angle there. Now, 2J angle KL is equals to 180 minus 50, which is 130. We divide by 2, J angle KL is equals to 65 degrees. Now, we do know this angle that it is 65 degrees. Therefore, we know that K angle J L is also 65 degrees, since there, that's what we said, this angle is equals to this angle is equals to that angle. It means that we have 65 degrees also there, since this is an isosceles triangle. Now, since we have JM parallel to KL, with these problems, we know that we can use theorem number 5. We can also use what we have used in part 1. As you can see here, we have used what we have learned in part 1. Therefore, now we are also using what we have learned in part 1. This angle is equals to that angle. There's your Z, or an N shape there. Therefore, this angle is equals to that angle there. Therefore, it means that M angle JL is equals to J angle K angle L, J angle L K, which is this angle, J angle L K, which is this angle there. Therefore, this angle is equals to that angle. Reason, interior alternate angles. Why are they alternating? Because JM is parallel to KL. Now, this angle, obviously, J angle LK, J angle LK is 50 degrees, which is equals to M angle JL, which is equals to there, this angle there, 50 degrees there. Now, we are told to find X. We must not forget that. Now we can be able to find X. Now, since MJKL is a cyclic quadrilateral, now theorem number 5 can apply for us to find X. And this is how we're going to apply it. M angle J, K, this angle, which is M angle J, K, this angle, plus M angle L, K, M angle L, K is equals to 180 degrees. Why this angle plus that angle is equals to 180 degrees? We know that this is a cyclic quadrilateral. MJKL is a cyclic quadrilateral. Therefore, it means that opposite angles of a cyclic quad are supplementary. Opposite angles of a cyclic quadrilateral are supplementary. Opposite angles of a cyclic quad are supplementary. Now, M angle JK is the same as this angle plus that angle. M angle JK is the same as this angle plus this angle, which is M angle JK. Therefore, M angle JL plus L angle JK. M angle JL, which is this angle, plus L angle JK, which is this angle, is equals to this angle, plus M angle LK. M angle LK is the same as M angle LJ, M angle LJ, plus this angle, which is J angle L, J angle L, K, which is equals to 180 degrees. What I did, this angle is just these two angles. This angle, which is that, is just this angle plus this angle. Now, we know this angle is 50, plus we know that this angle is 65 degrees, plus we know that this angle, M angle LJ, is X, plus we know that J angle LK, J angle LK is 50, equals to 180 degrees. Now, this is 100 plus that, which is 165 degrees, plus X is equals to 180 degrees. Now, X is equals to 180 degrees minus 165 degrees, which is 15 degrees. The value of X. Therefore, this is how we can use theorem number 5 to solve for this. Now, let's look at the example on theorem number 6. The example on theorem number 6, this is what we are given. X, Y, Z, T, we are told that X, Y, Z, T are points on the circumference of a circle with diameter YZ produced to H. Therefore, this diameter YZ is produced to H. We are also told that T angle ZH is equals to 120 degrees. We are also told that X angle OY is 70 degrees. Now, we are told to find the value of X. Now, for us to find the value of X, we have seen with the previous examples, we only use probably the theorem once. Then we use what we have learned in part 1. Even in part 3, we are still going to look at eliminating theorems. Then the theorems that are going to be left on a problem together with part 1 is what we are going to use to solve that problem. We will see when we do part 3 on exam question papers. But here we can see that for us to find the value of X, we can find this angle there. Finding this angle there, it will help us because we know that this angle is equals to this angle, which is your exterior angle of a cyclic quad is equals to the opposite interior angle. So it will be easy for us to find X if we can find this angle. Now, for us to find this angle, we know that this angle is equals to that angle. Since this and that, this radius is equals to that radius. So we have radii here. Therefore, this angle is equals to that angle. Then we can be able to find that angle there. Let's find X angle Y O is equals to Y angle X O. We say this angle is equals to that angle. That's what we mean here. Therefore, reason, we know that triangle OXY, triangle OXY is isosceles triangle. Why is it isosceles triangle? OX is equals to OY. Now, we know that this angle plus this angle plus this angle, this angle plus this angle plus this angle is equal to 180 degrees, sum of angles on a triangle. Therefore, X angle Y O plus Y angle X O plus X angle O Y is equals to 180 degrees. X angle Y O, which is this angle there, plus Y angle X O, which is this angle there, plus is equals to 180 degrees. Reason, sum of angles on triangle XOY. Now, this angle, X angle YO, X angle YO, this angle is equals to that angle. So here I can put this plus this. This here is the same as saying this plus this, because this is equals to that. So I can put there Y angle XO. Therefore, y angle xo plus y angle xo is going to be 2y angle xo plus x angle o y, which is equals to 180 degrees. Now, we are looking for this angle. We know x angle o y. Therefore, we have 2y y angle xo plus 70 equals 280 degrees. Therefore, 2y angle xo is equals to 280 minus 70, because 70 goes to the other side of the equal sign, which this becomes 110. But obviously, this is 2y angle xo. We divide by 2, divide by 2. Now, obviously, y angle, just need to remove there. This is an angle. Y angle xo is equals to 55. Because this will cancel, then you're left with y angle xo, which is equals to 55. Now, it means that here we have 55 degrees. Most times when I get the angle there, I write it so that I can see what I have already. Now, I can find x. And how do I find x? X, y, z, t are points on the circle. So if they're points on the circle, it means that this is a cyclic quadrilateral. And if it's a cyclic quadrilateral, then we can say y angle x t is equals to t angle z h. This just simply means that y angle xt, which is this angle there, the whole of this angle there, is equals to t angle z h, which is this angle there. Reason, exterior angle of a cyclic quadrilateral is equals to opposite interior angle. Exterior angle of a cyclic quadrilateral is equals to opposite interior angle. Now, y angle xt is the same as this angle plus this angle. Y angle xt is the same as this angle plus this angle. Therefore, there I'm going to put y angle xo, because it's this angle. Y angle xo plus o angle x t is equals to t angle z h. This is equals to that. It's one and the same thing. This is equals to that, because y angle xt is the whole of this angle, and the whole of this angle is the same as this plus that. That is what you see there. Now, this angle there, it is 55 plus. This angle there, it is x, because it's O angle xt which is x, which is equals to T angle ZH. T angle ZH is this angle there, which is 120 degrees. Now, we take this, that side. X is equals to 120 degrees minus 55. Now, 120 degrees minus 55 is the same as 65.